Now the good news is that the multiplying polynomials part of the assignments, that is part of week 2. I think it came up last week, and I wasn't sure off the top of my head which one I had put it on, week 1 or week 2, but it is part of week 2. So none of this is due tomorrow night. The bad news is this will be on the quiz on Wednesday. So we have whatever we have left today to review, which isn't much. It looks like it'll be about 10 minutes, but then tomorrow's also a review day. I wanted to be able to get some of you guys to come up to the board today, but we'll do that tomorrow. I'll just try to get through as many of these as I can, and then tomorrow we can spend a little more time having you guys come up and do reviews and stuff like that. Question? The or something. Okay, so what we've done before, we've added and subtracted polynomials. So that you know hopefully how to do for Wednesday's quiz. I was actually even able to review that. So if you were paying attention to that, we had a quick refresher on that. What's the main concept I have to understand in order to be able to add and subtract polynomials? Yes. Combine like terms. Okay, but before I can combine like terms, if there's any parentheses, I have to remove them. You know how to remove a parentheses when there's one single term outside of it. In some cases, it might just be a 1 or a -1. In some cases, it might actually be a term that has variables. What we haven't done, though, is multiply more than one term times more than one term. If you are specifically multiplying two, oh, come on. If you are multiplying two binomials, then the process can be referred to using the acronym FOIL. I like to use that word as a verb so that if we're working on simplifying an expression and the next step is to multiply any two polynomials and I say, hey, what are we doing next? You can tell me FOIL. But using the acronym first, outer, inner, last only really helps you with specifically binomials, so I don't really see the point in trying to emphasize it. But we will refer to the process as FOIL. I think what we're about to do now, this slide, they call it box method. I haven't really heard that, but fine. So the way I'm going to approach all of these, so we can do the same thing every time, is identify the first term in the first parentheses. Ready, set, identify. What is it? What is the first term in the first parentheses? H. And I'm going to get that H and I'm going to multiply it times every term in the other parentheses. Even if there was 5 different parentheses, I can only multiply 2 at a time anyways. The arrows I draw to give you a visual, I actually prefer that you don't draw them if you really need to. Some people, but it helps me. Fine, I guess, but I'm just showing you visually what I'm going to do on the board. I'm gonna distribute. Foiling is distributing repeatedly. If you understand distributive property, you should understand FOIL. It's just distribute more than once. H times, every arrow represents multiplication. H times 6H is? 7H. Oh no. 6H. 6H squared. Multiply, you multiply the numbers in front. 6 times 1 is 6. H times H is H squared. H times -1 is? Negative H. 2 times 6H is? 12H. Oh, I'm sorry. You know what? Maybe I went too fast there. Once I did H times -1 and I got negative H, I am now done with the H, so I'm about to do the same thing now with the 2's. I move on to the next term and I distribute that one. If I had 5 different terms in the first parenthesis, I would distribute every single one, but always to the other one. 2 times 6H is? The 12H, we wrote that. 2 times -1 is -2. When you just do plain distribution, however many terms you start off with in the parentheses is whatever you should end up with. When you FOIL, how many terms in the first one? 2. How many terms in the second one? 2. What's 2 times 2? How many terms did I end up with? 4. Eventually, when we get to the example that's binomial times trinomial, what's 2 times 3? 6. I'll end up with 6. Here's another tip. assuming that the original polynomials are in standard form, which these are. Assuming all polynomials are originally in standard form, any like terms, which is what we're going to look for now, will be in the middle. So drop down 6h squared, drop down -2. In the middle, what's -h plus 12h? Plus 11h. Any questions? Okay. Let's at least get to this next page of 2x2 foils, and then that way tomorrow we can start on the 3x2s. If I wouldn't have had to do all the stuff on con, I could have had you guys come up and do this, but we can do it tomorrow. Let's just do this first one together up here. What's the first term in the first parentheses? 2k gets distributed to each of these. Normally, I'm not going to draw the arrows. This is just as an introduction. 2k times 3k.
6k squared.
NBA 2k? It's 6k squared. 2k times 10 is plus 20k. I am now done with the 2k. So now what am I going to distribute next? -1. -1 times 3k is -3k. -1 times 10 is -10. Any questions so far? Somebody, was it this period or might have been last period? Somebody asked me, oh, can we go ahead and start the week 2 stuff already? Of course, we're in week 2. Make sure you finish week 1 first. Let's do tomorrow, but this is the stuff already in week 2 if you want to practice. The only like terms are in the middle again. So 6k squared plus 17k minus 10. And the last one for today. What's the first term in the first parentheses?
P.
Lovely. What's p times -p? Just lovely. Very good. Negative p squared. Negative times positive is negative. TJ, what is p times -3? P times -3.
Oh,
-3p, good. Jay, what's 7 times -p? No, 7 times -p. -7p. Deshaun, what's 7 times -3? -21. Okay, just like before, the like terms, they're not always, it depends on how they were arranged originally, but they are in the middle. So I have a -p squared minus 10p minus 21. Any questions there? Tomorrow we'll be able to start off right from the beginning. We'll go straight into finishing this off, and then we can do some practice for the quiz. Yep.